Hello and welcome everyone. Myself Amit Kapila. I am contributing in Postgres for more than 10 years and I have overall more than 2 decades of experience in databases, primarily in Oracle and PostgreSQL. Today I am here to share with you the latest developments in PostgreSQL, primarily what is planned for Postgres 17, which is going to get released later this year. And then I will also discuss a bit about what's being discussed in the community for next releases. Before going into the actual presentation, I would like to give the bigger picture for a minute, like how the Postgres has been evolved over years. So after it got inherited from university with the initial version of 6.0, we have from 6.0 to 9.6, we have added numerous number of features in PostgreSQL to make it ready for the enterprise or bigger applications rather than just a university project. So starting with 6.0 to 9.6, we have added numerous number of features starting from streaming replication and synchronous replication, where we have enabled it for failovers or high availability. Then also another set of features we have added, like JSON-B and JSON data type and index-only scans. Parallelism has been added in 9.6. So by adding all these features, the Postgres started to become a mainstream database. Then from there on, with 10 till now, we have added features to make it enterprise class Postgres, where now we can see that many of the major companies like AWS, Microsoft, or Google has also forked their databases from Postgres or providing the service for Postgres in one or the other way. So in the 10, we have added declarative partitioning and logical replication, which were really very big 2 features in one release. Then from 10 till 12, we have done a numerous number of improvements in the partitioning, like with 11, partitioning by hash key has been done, and then performance improvements in 12. In the 11, we have also added SQL stored procedures, which help people to migrate to from other databases like Oracle or other databases to Postgres. Then with 12, we have added table access methods, which helped other pluggable storage engines to write their specific storage needs with Postgres. So with 13, we have added some features like parallel vacuum, where each worker does the vacuum for each index, which improves its speed, and then deduplication in B-tree index and incremental sorting. With 14, we have improved the reads by improving the snapshot scalability at very high client count. And then we have also improved logical replication to reduce the lag for very large transactions, or by applying it in the in-progress transactions. Then also we have reduced the bloat for B-tree index updates and added parallel foreign table scans via Postgres FTW in 14. With 15, we have added merge command, which help various users of other databases to also use the same feature in Postgres. Then we have moved the statistics from backend to shared memory, which helped us to add more number of statistics in the coming years in Postgres. We also then again improved logical replication by adding row filtering and column filtering in it, and server-side backup compression for it. Then with 16, we have started to allow logical replication from the standby, logical replication from the standby, which means load could be distributed between primary and standby for logical replication if required. And also parallel apply for large transaction, which again reduces the apply lag. Then we improved our SQL JSON standard compliance and improved the bulk loads by making faster relation extension, and load balancing via libpq. In the next release, which is going to happen later this year, which will be probably named as Postgres 17, we are again doing a lot of features which I am going to cover in the upcoming slides. But here, like failover slots, which actually allow the logical replication to continue even after the failover without any breaks. And then incremental backups for very large backups. And then we have done a numerous number of improvements in the vacuum technology, and one of the main was removing the 1 GB limit during vacuum cleanup. And then again, we have strengthened the SQL JSON compliance by adding JSON table kind of features, and also improved the partitioning by adding split and merge partitions. So next I will cover these features in detail, like what are the key features and performance improvements done in Postgres 17. So the first feature I would like to speak about is incremental backups. So this feature is primarily to allow the large backups to be taken incrementally. So the basic idea is that we will, after the base backup first time, we will only copy the changed blocks in the incremental incremental way, so that the amount of backup data in the backup gets reduced. And in the end, users need to use a PGCombine backup tool to reconstruct the backup from the first backup upon which the incremental backups are based. And to take the backups, user can use incremental option. And also behind the scenes, the technology is that there is a new background worker which gets enabled with GUC, and it keeps summarizing the walls. By reading the walls, it keep computing the change blocks, which are later used to copy the blocks incrementally. Then the next big thing we have done is improved a number of things in vacuum, which overall improves auto vacuum and vacuum performance. So the first one is that we, for the vacuum cleanup, we started to use TID store to collect the dead tuples from the heap and use that to clean up the index. So the basic thing is this data structure makes the collection succinct by reducing the amount of memory it used to take to collect the dead tuples. So overall, after this feature, the multiple passes of vacuum, which they used to do the cleanup when the tables are very large, will be now a very rare operation. And also the index lookup, which needs to be performed when we are cleaning up the index, also becomes significantly faster. So overall, this makes the large table vacuums quite efficient as compared to the prior release. Then we have also made a number of optimizations to reduce the wall volume during vacuum, like by combining freezing and pruning steps so that the wall for those are reduced. And when there are no indexes on the table, then we reduced one step that items on each heap page can be directly marked as unused instead of first marking it as dead and then unused. So overall, these second and third reduces the wall volume, which earlier gets generated via vacuum, which in turn improves its I/O and sync speed as well. The next enhancement is basically we have introduced new streaming APIs, which allows us to prefetch and read the data in chunks by using new GUC I/O combine limit. The basic theme is that this is sort of part of the infrastructure for the asynchronous I/O. But we also started using it from this release in the sequential scans, analyze, and PG preform. And during the tests, not only by community, but by the external members, I have seen some videos where we have seen that there is a noticeable improvement in the sequential scans, and also which implies that the other operations listed here gets improved due to this. So this is really a exciting optimization because it applies to large number of users where sequential scan is used. Then we also improved the performance of our SLRU subsystem by introducing the GUC for the caches used via the SLRU. Basically, to just give you a brief, the SLRU subsystem is used primarily for storing the transaction data or sub-transaction information, multi-act information, things like that. And when, say, number of sub-transactions become very large or multi-acts become very large, the performance used to hamper because of the cache sizes. So various solutions were discussed, or I would say still under consideration, started from moving SLRU subsystem to the main buffer management. But for now, we decided on a solution where we make our cache sizes configurable, and also we further subdivided our cache, SLRU caches into chunks which we named as banks, so that the eviction mechanism has to search only one bank of the cache. Now, going further, we have also improved our locking regime, which is used to allow multiple people to access the SLRU system at the bank level rather than at the full SLRU cache level. So the more information you can see from my colleague Dileep's presentation. So this really helps for this significantly helps for the systems or the loads where the number of sub-transactions or the load is very heavy on the SLRU system. Then we have also enhanced, like with each release, the table AM. In this release, we allowed table AM to skip the heap page if the data is not needed and it is marked as all visible in the visibility map. Prior to this, this was feature being internally used in Postgres for bitmap heap scan, but now the pluggable engines could also use this feature via the Postgres table AM API. Then we have optimized the array search in the B tree, which at the user level will help the queries which has in or any subclause. Then going further towards the performance improvement, we have improved the write performance where at a very high client count, say 256 or more, where the bottlenecks at the lower level of the wall has been reduced by changing locks to atomic operations. So because these are, these days high client count is not a very rare thing, so I feel this optimization will also help quite a few generic workloads for Postgres. So I have summarized my presentation into various feature performance based on the different subsystems like storage, logical replication, SQL, JSON, like that. So if you have any questions in anything, maybe we can take it now also or at the end as well. So next I will talk about some of the enhancements in the logical replication. So the first feature which we were discussing or being demanded for a number of years now is to allow the failover for logical replication, which means that once the primary or the publisher node goes down, the subscriptions would stop to proceed. But with this feature, we allow the failover kind of thing where even if the primary goes or the publisher node goes down, the subscription can still continue getting the data from the physical standby. So the main idea behind this feature was, or the technology behind this feature was that we started copying the logical slots corresponding to subscriptions from primary node to standby. There are various ways we have exposed for users to do this. One is via the inherent way by using the GUC we enable, which enabling will enable the slot sync worker on the standby, which keeps pulling the data periodically, logical slots from the primary node to standby node. Then we also provided an API. For example, users who doesn't want to use Postgres, or they are specific that they want to only copy the slots at the just before planned switchover. So users can use an API PG sync replication slots, which will sync all the logical slots, and still users can continue the logical replication, or the subscription can follow the standby after failover or switchover. So,
yeah. What happens if you have multiple standby servers? Do they all get the slot?
So cascading standby, no. As of now, we didn't see the use case of getting multiple standby. So this, and for the simplicity, we restrict this feature to one physical standby.
How is that determined?
So if we give the error, or if on the cascaded standby you enable the slot sync worker and which tries to get the data from the standby, it will give error, or it won't proceed from there. Or if, say, you started using this API sync slots from cascaded standby to a normal standby, it will give you error. By default, we don't copy all the slots. We copy only the slots for which the failover option is marked as true. And this failover setting or property could be marked both via for the subscription via the subscription command, and even for directly created logical slots via the SQL API Postgres exposed to create the slots. So this is primarily a high availability feature with respect to logical replication. The other big thing we have added for logical replication is to allow major version upgrades with logical replication setup. Prior to this release, even after you do the major version upgrades, all your logical replication setup will go because we don't retain the slots from prior version to the newly upgraded version, and neither the subscription relation information. So users do have their tools or the primary script, their own scripts to do to reset up the logical replication again after the upgrades. And I have seen in many cases that users need to truncate the prior data and need to reset up the logical replication from the beginning, or copy all the data at least. So with this feature, it works without user intervening into it. And for this feature, the primary two things we have achieved are, during upgrade, the slots from the prior version to the newer version is retained, and also the subscription relation, like all the relations corresponding to subscription on subscriber, that information, meta information, is also retained. So this feature will be available only when the old server version is 17. So ideally, this is not a very pleasing situation, but you will be able to use this feature when you are upgrading your clusters from 17 to 18. Then we have done a number of another enhancements into logical replication as well. For example, we have improved the speed of our decoding process when there are large number of sub-transactions in a transaction. So for example, for a transaction which has 100K sub-transaction, there is an improvement up to 30x has been observed. The primary idea is that when the decoding process memory gets full, then we used to find some transaction or sub-transaction which we can spill or stream so that we can logical decoding process can continue. And to do that, it used to perform a linear search to find the appropriate transaction which could be spilled. With this new methodology or new optimization, we while storing the transactions, we store it in a max heap form where the largest transaction could be found in O1 time. Then another smaller enhancement is that we allow the hash indexes to be used for lookup during apply when primary key or replica identity key are not available. Then we also started to provide a new tool, PG create subscriber, which allows the initial subscriber setup from a physical standby. So what this helps is that during the initial replication setup or the subscription setup, we need to copy the required tables, all the tables. So for smaller tables, this works fine, but when the data is large, copying each of the individual table takes a lot of time. Whereas using this tool where we set up the initial subscription subscriber will be directly from any physical standby, we can do that. It improves the performance for large databases significantly. Then a side use of this tool is also that this could be used in PG upgrade process in some ways. Like you can see if you people are going to my colleagues Kuroda-san's presentation on how the upgrades with logical replication works in the new release. In that we have explained in detail how this tool could be used even during major version upgrades. Next, I will share with you some of the enhancements we have done in the SQL. Like to start with, the first thing is some of the improvements in our partitioning methods. Like we started to provide the facility where users can split or merge the partitions. Basically, like when there are large number of partitions and those are no longer required, they could be merged into one partition using the parent table partitions schema. And similarly, sometimes when one of the partition becomes too big, it could be splitted into multiple partitions using the parent table schema. We do have certain caveats or restrictions here, sort of like for this entire split or merge operation, an access exclusive lock has been held on the parent table, which would block other concurrent operations on that table. And then we also allow only non-partitioned partitions can be merged or splitted. And these operations are not supported for, as of now, hash partition tables. So some of these could be uplifted in the coming releases, but as a base feature, people think, or we think that this is a good use case for, this helps with a number of cases for people.
Would this be kind of the start of being able to take a non-partition table and turning it into a partition table?
No, that is, we already have some facility like attach partition or detach. Those could be probably used to attach non-partition table into this. So this is primarily the existing hierarchy of the partition you can operate on with these features. Then we also started supporting identity columns in the partition tables. A newly created partition inherits the identity property from the partition table. This means that an identity column shares the same sequence, same underlying sequence of the parent partition table. Whereas in regular inheritance, child and parent doesn't share such a relationship. And now a table attached as a partition could also inherit this property. And also the table being detached will lose the identity property from after getting detached. Then we also started allowing specifying the exclusion constraints on the partition tables, provided that the partition key would be used as an equality operator in the exclusion constraint. For example, if you see in the first part of this example, first black box, like A is the partition key, which is not used in the exclusion constraint, so we get the error. But contrary to that, in the second example, when both the partition keys are used as with the equal operator, that would be allowed. Then we have made some improvements as with each release into parallelism also. For example, now multiple workers can be deployed to build a Brin index where each worker summarizes the subset of the table and store these into sorted form. And the leader read these sorted streams and merge it into the main Brin index. So we saw that for CPU-bound index creations, this significantly improves the create index speed. Then we also started allowing queries which generate init plans with init plans pushed down to the workers. So these are some of the examples where the parallelism could be deployed and the further performance will be increased. Then we also, next I'm going to talk for next few slides about the different kind of queries which we have improved via various optimizations. So in this case, we started to, is not null query restrictions could be dropped when applied on the not null column. And similarly, the entire scan could be eliminated if is null is specified on not null column, because that is no use of doing any scan for such columns with such a clause. Then we also started using the joins or convert the correlated in subqueries to transform into a form where they started to use joins, which also as the plan got improved, the query execution speed also improves in such cases. Similarly, we have also improved the CTE plans by considering the statistics and sort order of columns referred in earlier row output clauses. So again, this slide explains some of the queries or some subset of the queries which could be, which one, if used, will be improved in this release. Then a few type of query enhancements for Postgres FDW. With this release, we started to push down the clauses like exists and in subqueries to the remote node, to the remote Postgres FDW. And similarly, we allowed joins with non-join qualifications to be pushed down to the foreign server and custom scans. So when we push down some things to the foreign node, this means the number of rows, more number of rows get filtered at the foreign server itself, and lesser data will be transferred to main node. So this also again improves the speed of such usage or usage of queries. So after introducing a merge command in the 15 in this release, we further improved the merge commands usage by allowing the returning clause and a new function merge action. So where returning helps us to return the data merged into the target table, and the merge action also helps us to find which exact operation has happened in the merge command. Then we also supported when not matched by source clause in the merge command, which operates on rows that exist in the target table but not in the source table. Then we also allowed merge command to modify the updatable views. We also now introduced the login triggers, login event triggers, which helps us to find the information at the login time itself. So basically, users can use this to disallow logins for a certain period of time, or they can also verify the connection and assign different kind of roles depending on the circumstances. And such triggers could also be invoked at the standby servers. Then we have also, next we have also improved speed for number of parallel aggregate functions listed here by reducing the pallocs and memcopy during the deserialization operation in these functions. Next, we have introduced a built-in collation provider. The main idea of that is the new collation ensures that the return values of the sorts won't change regardless of what the system your Postgres installation runs on. So this is a step towards like breaking due to collations when we switch from release to release, and we have a lot of Postgres reports with that. So at this stage, we only support C and C.utf locales for this provider. The C locale is quite identical to the what is provided by libc. And C.utf locale is available only when the database encoding is UTF-8. So time is less, I have to move a little faster. So then we have also started to allow executing these vacuum cluster, all such commands without the super user privilege with the help of maintain privilege on the table or by assigning PG maintain role to the users. Then we also allowed TLS connections without a network round trip by using client-side option SSL negotiation equal to direct. Then alter system command is also improved to allow changing the unrecognized custom server variables, and one could now disallow alter system command by using the GUC, which is quite useful for environments where configuration is managed by external tools. Then we have also strengthened our SQL JSON standard compliance via introducing the JSON table. You can see from the output here that the JSON table's data is converted to the tabular format by using this function. Then for the sake compliance, we have introduced a new constructor functions like JSON, JSON scalar, and JSON serialize. On the similar lines, we also introduced JSON, SQL JSON query functions like JSON access, JSON query, and JSON value. We also have improved our monitoring system by making few new columns in the PG stat progress vacuum, and also we have moved the required checkpointer data to the PG checkpointer view. Then we improved our PG stat vacuum progress view as well by adding few more columns to track the vacuum progress. And for some users who would be using old snapshot threshold GUC, we have removed this due to a number of issues found in this feature. Basically, this feature was the parameter defines the time threshold for a snapshot during which old row versions will not be deleted. I think this is some of the key features I have covered for Postgres 17. Full list is mentioned here. You can go through it. Now I'll quickly go through some of the features for which are being discussed in community for the next releases. So none of this is claimed to be provided in any next or the future releases. First one is transparent column encryption and decryption of particular columns in the client. Then asynchronous I/O, for which some of the basic infrastructure is added in the past releases. So this should improve the performance of Postgres across the board, like various operations, vacuum, sequence scan, all kind of things. Then also import and export of statistics have been discussed so that after upgrading your database major version upgrade, you don't need to run analyze again to make your queries perform better. A number of enhancements in table AM, APIs, and AM check module. Then for logical replication, we are also improving. There are multiple proposals like DDL replication, conflict detection management. Mostly it is moving towards the active-active solution. Then a set of execution improvements like a JIT compilation per plan node, special case executor expression steps for common combinations. Then a SQL standard row pattern recognition feature is also being discussed. Then as in this release or previous release, lot of partitioning performance improvements have been under discussion, especially the partition pruning when large number of partitions are present, and improvements in indexing like B-tree, optimizer module, and like that. And then we also are discussing a wire protocol level compression, which will reduce the network I/O. I just hope that we get such features. Then a number of improvements in parallelism, like parallel vacuum for tables, parallel create index for GIN indexes, correlated subqueries and TID scans to be parallelized. Then few big features like 64-bit XIDs are under discussion from a long time, and still their discussion is active. Then wall headers, we want to reduce the size of that, which will across the board reduce the wall volume and improve performance. Then some toast improvements like custom formats, compression dictionaries, improve our monitoring system via stats, and the CI build system. So tons of improvements are being discussed. Overall, I want to say that if you see release by release, Postgres is improving. And it is not like we are improving in certain area, like only partitioning or only vacuum or only logical replication. If you see, in each release, the SQL queries are improved, logical replication is improved, partitioning, parallelism. So improvements are across the board, which is really good and making Postgres more and more usable by the industry. Thank you. I think this is all from my side.
In slide 10, you said that you can upgrade the logical replicas.
Yeah, 1 minute, let me go there. Yeah.
Here, right. So you said this can only be done for version 17 and later. Is it possible to, say, write an extension or something that would...
Yeah, I think, yes, it was possible to write an extension to do this. But for certain set of restrictions, we have not done this for prior releases.
No, but I mean, is it possible that now that we have whatever it is that we have, can we now write something for 16 or 15 that can be used to upgrade it to 17? Or is it something that cannot be done in extension?
1 minute. I think if you are going to use the PG upgrade tool, it would be not possible to, write. How will you update the extension to be upgrade the PG upgrade module? It is inbuilt in the PG upgrade. The checks are there that it will not allow the prior version where
It would need some patches to core if you were backporting, and I know the community won't backport itself. But
yeah, basically, yeah, you can say I have a fork in Fujitsu. If I want, I can tweak some checks in that fork where you can do it. But there was a discussion during the time that whether we should enable it or not, but it was not decided that we should support it for prior versions.
Yeah, I think the point Dennis is making is the right one, which is that core does not have it, but maybe others can.
Yeah, but I think Dennis' point is making, he means to say that the patches to the core could be need to be submitted to get it done. To the extension, possibly we can discuss, but I don't think it is so easily possible that then you can write some function to just tweak and get it done. Because the checks are inbuilt in PG upgrade module.
Okay.
and what I was thinking is that there are possible patches to core that be hooks or whatever that might be applicable to 16 and 15 that the community wouldn't necessarily accept, but several companies may want to sort of agree on this is the way.
Yes, yes. So that way it can be done.
To do certain things. So there's those back patches wouldn't necessarily get into core, but they may be cooperated on across multiple companies interested in these features, including supporting it.
Yeah, I think that is possible. Yeah.
Since you were a little rushed there, I was wondering if you had more to say or some ideas about the improvements we're looking at towards active-active nirvana, if you will.
Yeah. So if we see, I think the question, correct me if I'm wrong, the question is what kind of, he wants to know more about active-active, like what kind of things we are discussing in community to move Postgres towards active-active. So as per my understanding, the two key features to move towards the active-active are conflict detection resolution and some cluster-wide sequences. Of course, then if we want a true active-active, DDL replication should also be there. Then some node management APIs should also be there. But I think without concrete or a good conflict detection resolution, solution is not even up to the level where it could be considered for true active-active. But I hope that in future releases we move towards that and provide to a good extent the solutions in core. Does that answer your question?
Yeah.
So I think we are done. Okay. Thank you very much. Thank you.